Welcome to the presentation on SR latches, also known as SR flip-flops, RS latch, set reset latch, and reset set latch. With an active high input and is made up of NOR gates. Here's our truth table. Anytime the set is high and the reset is low, the result will be a set condition, which actually means the Q outputs will be 1 or high. Anytime that reset is high and the set is low, Q output goes to 0 or low. Anytime that we have two active highs, the result is an invalid condition. Anytime that both the set and reset are 0, there is no change to the output. Here's an active SR latch waveform. Here we have a set high and reset low, which our output would be a set. Here we have set low and reset high, outputting a reset 0. Again, set high and reset low outputs a set 1. Set low and reset low would be no change. Set high and reset high would be an invalid condition. This is an SR latch with an active low input and is made up of NAND gates. Here's our truth table. Anytime set is low and reset is high, the result will be a set condition, which means the Q output will be 1 or high. Anytime reset is low and set is high, the Q output goes to 0 or low. Anytime that we have two active lows, the result is an invalid condition. Anytime that both set and reset are 1, there is no change. Here is an active low input SR latch waveform. When set goes low and reset is high, we get a set on Q. When set is high and reset is low, we get a reset on Q. When we have set low and reset low, we get an invalid condition. And when we have a high set and high reset, we get no change. Here is an active low SR latch used as a debounce switch. Debounce switches eliminate the noise caused by mechanical switch bounce, which produce multiple false signals. This one is going to be pulled high and the input will be a low. Once it is switched, it will latch until we change the input. This is an active high SR latch used as a debounce switch. The active high input uses pull down resistors and will be using a high input. This is a gated SR latch with an active high input. The gate will be activated only when the enable is high. Once it is enabled, it is an active high SR latch. When it's disabled, the output would be latched. Here's a waveform for a gated SR latch. The gate is active only when the enable is high. Anytime the enable goes low, the output will be latched. Here's an example of an active high input SR latch. As you recognize, here we have NOR gates and no bars or bubbles on our symbol. Here's a waveform for an active high input SR latch. Here is an example of an active low input SR latch. Notice we have NAND gates and we have a bubble or a bar that represents the active low input. Here's the waveform for an active low input SR latch. Here's an example of a gated SR latch. Notice we have enable, S, and R inputs. Here is a waveform for a gated SR latch.